Okay. This is where you'll download your software. The links are everywhere. I'm going to stop repeating myself about that. So, why do we want you to go find roosts? Number one, they're awesome. Photography, videography never does it justice. It doesn't even approach doing it justice. So you've got to check it out for yourself. It will make an impression. People love it. So if there's one near you, I want you to go find it. And part of that is finding ones that maybe nobody's seen or nobody's noticed, but we see them on Weather Radar. So this on our website here, Project Martin Roost is one of our citizen science projects. It's our third one, a little lesser known, but we're looking to reinvigorate the participation in it. So that's why we're doing this. It's available when you go to our website, purplemartin.org, research, Project Martin Roost. You get yourself a map here, purple and yellow dots, similar to the Scout Arrival Study. The purple dots there are Purple Martin Roost that people have verified on the ground. They've done roost reports for us as a science project, and we'll show what that is here in a minute. Hey, Shannon. There's several questions that we want to know about the habitat that the purple martins are using and risks to that, or, just various information for scientific purposes, as well as, the obvious publicity possibility of it. It's a good look for purple martins. But all those yellow dots there are ones that have shown up on Weather Radar, and those have been rigorously mapped out by our friends at University of Oklahoma in the Radar Aeroecology Lab there. They do quite a bit of research using Weather Radar to study insects, birds, bats, anything that's not water in the sky, basically. Hey, Catherine. Puget Sound near Seattle. Yeah, no, we don't have... We don't have any roosts signified up there. Part of the problem here along the left coast is the mountains make the weather radar, and the topography makes the weather radar not kind of a universal scan. It doesn't reach very far. I'm sure there's purple martin roosts over there somewhere, and maybe with the tips from this and the software, you'll be the one to find one up in Washington. Okay, so when you do, so basically I want you to look at this map, find out where you live. Hopefully you can find yourself. Is there a dot near you? Even if it's a purple dot, I want you to go out there and do a report for us. Experience it. The purple ones are usually the ones that are easier to find. So, that shouldn't be a problem for you. The yellow ones are a bit of a scavenger hunt. So whenever you do locate the roosts, which we'll be showing you how to do, you'll go to our website, you'll log in with your username, and you'll submit a roost report. And it just asks for some information. Roost title, that really doesn't matter. You can just give it a name of the nearest city, or if you want to give it a fancy name, go for it. Nearest city, country, region, latitude and longitude is really important if you can do that. Otherwise, try to describe it in as much detail as you can. It's this many miles north of this intersection in the country or whatever. But ideally, you would give us lat and long, which if you can't do it from your phone, you can do it. Good idea, Kathy. I'll introduce myself here after I finish this. You can use Google Maps, and I'll show you in a little bit how to get lat and long just from clicking on a spot on the map. Is it active or not? Estimate the number of purple martins present. It's just kind of a fun exercise, and it's maybe more art than science for some folks because there's a lot of birds in the sky. How do you count them all? Species composition. what type of birds are there. Is it all purple martins? Is it all blackbirds? Maybe it's not a purple martin roost. There are other roosts that may or may not be purple martin roosts that are included in those yellow dots. Description of the roost location, that's where you would put the information on where it is so we can map it out for you. Description of the habitat, history of the roost site, when does it begin, when does it end. You can try that. Sometimes you won't know that. And for the roosts on the website, that function is not even working right now. I think everything says early January. So that's obviously not the case because the birds are just arriving. Threats and problems to the roost, opportunities. All this is fairly self-explanatory, but this is where, after you guys learn how to find a roost tonight, I want you to go out, find one, and then tell us about it so we can add it into our research database and learn more about how we can serve purple martins. Thank you, Kathy, for reminding me I didn't introduce myself. My name is Joe Segrist. I'm the president of the Purple Martin Conservation Association. I hope that you guys know what the Purple Martin Conservation Association is since you found this, but in case you didn't, you would... we are a nonprofit organization that conserves purple martins in Canada, U.S., and Brazil. Kathy, you would log in to the website just like when you report your scout arrival. And for those of you who are not internet savvy or you just have bad luck with our website, you can always call or give us that information in other means. But ideally, you would do it online. I got like a 1-minute video here to show you guys a little bit, if you've never been to a purple martin roost, what it might be like when you go. Hopefully you guys get audio on this.
We're gonna get seriously shat on. Starting kind of a swirling, soaring and swirling.
All right. Hopefully you guys had audio there. That was really cool. The whoosh of the purple martins as they come by, when they are swirling around and swoop past you, there's actual wind that they create when they fly by like that, and you can hear them flying and turning. All right, Brad, good to know. Yeah, if you could do a report and let us know, we'll get that updated. Hey, Tiffany. All right. So, quick primer on radar. Doppler radar is the latest and greatest thing. I'm sure some of you probably remember, I don't know, what was it, 20, 30 years ago when all the local weather stations were like, we now have Doppler radar. This is awesome. And they renamed all their radar to something cool like Weather Blaster 88 or something. Basically, radar works just like sonar in the movies for submarines. You know, it goes bing, and then it echoes off of something and comes back. It's exactly what's happening, only with electromagnetic waves, radar waves. And one of the things that radar is really good at picking up is the reflections of rain, water, snow, hail, and living creatures, in particular ones with a lot of water content like birds, show up really well on the weather radar too. Let's see here. So the way the weather radar spins around, it's an antenna just like you see on top of boats and stuff in old movies, spinning around and around and around, and it shoots out a narrow beam, and that beam shoots out and it continues in a straight line, but the Earth's curvature curves away from it. So in reality, that beam is reaching higher and higher above the ground as it goes out. And that comes into play in us trying to find purple martin roosts. It detects birds, but, wherever that beam cuts through the air, whether it's at a low altitude or a high altitude as it gets farther away from the radar station, affects how the signal looks. I guess you guys can't see that very well. There we go. This is the weather radar shooting off a beam of radar, and you can see as it goes away. And this is kind of a weird depiction of it, but in essence, it scans higher in the atmosphere. And what weather radar does, it actually spins around, and in each rotation, it's checking a different angle. So you have a series of different angles that weather radar does that we'll be able to select from with this software. The end result is you can look at different altitudes in different places. Okay. All right, I'll save this information for once we get started here. All right. Weather Climate Toolkit. Hopefully you guys have that installed by now. It is not very user-friendly, which is why I wanted to do this training session. And it throws up little windows all over the place on your screen. It's actually pretty annoying. So I think when you first start it for the first time, you get... Let me turn off this background layer. Try and emulate what you guys are seeing, maybe. Something like this. I've got rivers turned on here to help find things. Let me turn that off. And I'll show you how to do all these things here in a little bit. So don't freak out that I'm going fast. I just wanted to get reset. Okay, something like this is what you guys see initially. And the cool thing about this program is that it can access archival weather data. So you can go back years and years and years and look at, what did this weather look like on this day? Or where was the roost on this day 10 years ago? Ever since they installed those Doppler weather radar stations, that newfangled radar, they started, they started recording that data, and this accesses the data. So let me pull up my little notes on what we're going to do here. All right. Talked about Project Martin Roost, talked about the radar angles. Okay. So how do we load data into this? You can go here to Data Selector, this button. If it's not all the way already open, it'll say Data Selector in the window. And what you need to do is go to NOAA Big Data. And hopefully you guys can follow along here. The thing about this software is it throws these windows all over each other, and it's really kind of a mess. But you want to make sure this says Nextrad Level 2, which I think is the default. Amazon, all this data is actually held on Amazon servers, Amazon.com, just like you would know. And here we've got a pull down with all of the different radar stations across the country, and we've got a calendar. So let me pull up a map of... Nope, that's not it. That's not it. There we go. This is all of the different radar stations across the United States, and they're little abbreviations. They all have little weird abbreviations that sometimes make sense with the name, sometimes they don't. But this shows you kind of how it falls apart over on the West Coast. You know, here we got these nice concentric circles with almost no mist areas. But this blue is kind of areas that are poorly served by weather radar. So presumably their forecasts wouldn't be accurate there, and they wouldn't necessarily get warned of storms and that sort of thing. But you would need in the Weather and Climate Toolkit to know which radar station you want to look at the data for. Paula, I'm sorry, it's not available on iPad, but there is some software that's pay for the software. It's not free for mobile devices. So let's just dive right into it. I want to look at a roost in South Carolina. So, oops. Here we go, South Carolina, and we're going to use this radar station right here. KCAE is the name of their radar station. So here we would pull this down, and they are in alphabetical order. So you would scroll to KCAE, and we're going to look at the radar from a couple of days ago. Catherine, I think this is going to be recorded. I'm not going to have the steps written out, but you should be able to follow along on the recording. We're going to look at July 15th, so last Wednesday. So you'd make sure you have those both in there, and then you're going to click List Files. And then it gives you this, and it puts its window in the way again. So what you have here is each scan from when the radar went around. So every few minutes, it does another cycle. So you've got, 3 in the morning, or 12:03 in the morning, on and on and on. Every few minutes, there's a scan. The weird thing about using this software, which endlessly confuses me, even though I know I need to calculate for it, is that this is not the local time on the ground. These times here, this 0 hours, 3 minutes, 16 seconds, is Zulu time, Greenwich Mean Time. So that's over in Europe. It's just the standard time that this uses. So it's not, you're not dealing with local time zones and having to figure that out. I guess that's a benefit, but the end result is you need to do a calculation in your head or on paper, or ask Google to do it to figure out what time you're actually looking at. So in the Eastern time zone, this is the cliff notes for this. If it's standard time, it's not daylight savings time. So whatever dates that is in the year, you would add 5 hours to this. So this would be 5:03 and 16 seconds. That's where it would start. You would add 6 hours for Central, 7 hours for Mountain, 8 hours for Pacific. If it's daylight savings, which we're mostly going to be using daylight savings because we're looking at purple martin roosts, you would add 1 less hour than that. So you'd add 4 hours to it for Eastern, 5 Central, 6 Mountain, 7 Pacific. So you're adding that to this. So we're going to look at purple martins taking off from this location in Columbia, South Carolina. That's just where this radar is stationed, in the morning. So we want to see when sunrise is. So I'll ask Google that. Sunrise. What is it, Columbia? All right. On July 15th, it was 6:24 a.m. And what did we say? We needed to add 4 hours. So 10:24 on the Weather and Climate Toolkit is when sunrise was. So we will find the closest scan to 10:24. It looks like we had one 3 minutes before sunrise. When I scroll down here, 10:21, 46 seconds. Highlight that. This information all should be how it started. And you click load. Actually, I did this button. This would be checked when you start up as a default, and that actually is helpful. All right, so we got a mess here on the screen. This, Sheila, it's sometimes listed as minus, but for this you need to add because we're converting the other way, if that makes sense. We're converting from UTC to the local time. Usually they say UTC minus 4 hours, and that's how you convert your time zone back to UTC. That's the difference there. Okay, so this software gives you unfiltered data. So you never see radar that looks like this on your weather channel or local news, because they filter out biological scatter, which is what purple martins are, and the very low level reflectivity. But I know for a fact that none of this is rain on here right now. So looks like we got something that looks like a circle here, maybe here. I know the one that I want to look at is closer to Columbia, which is, my guess is this is the highways, these red lines. Usually a little circle like that is the city. And I think that might be it right there. So what you do when you're hunting for a roost, you just go a little bit at a time. Let's try the next scan, see what happens. Click it, load. All right, a little bit of change. These are definitely changing, right? Check the next one. Okay, still nothing there. That's weird, right? These ones are definitely getting bigger. But what I mentioned before about how the beam gets higher as it goes out. So these are picking up birds that are, if you're hovering your mouse over the screen, down here in this box, I can't hover and point at the same time, is Z, which is the height. Yours might be in kilometers. I changed mine to feet and meters for this. So that's almost a mile high right there, 6,000 something feet. The one that I think is in existence is up here. So maybe that one's already gotten dispersed above the radar beam. So let's go back the other way. So what did I start at? I don't know, something like that. So right now, yeah, we're looking at 612. There's something. Let me go back. Okay. It's not quite the grandiose circle on the radar, but I know for a fact this is a really big roost. So I'm using a known one here so we can test to see how accurate we are. I just know it's in that area, which is kind of what you'll have from using our map for Project Martin Roost. So you can scroll forward on your mouse to zoom in, or you can click this little plusy thing here, little magnifying glass, and you can click, or you can draw a little square like this. You can do it like that. There's multiple ways to zoom in, but this is the spot I'm looking for here. I like to actually keep it on the hand so I can click and slide it around, and it'll kind of refill as you move. Okay, let me continue to move around here, forward and back in time, just to see if this is the right spot that I'm looking for. Oops. All right, so this happens. I'm glad that I made that mistake. So this reset zoom button that I clicked on before to move us in to just this radar station. If you leave that clicked in after you've zoomed, it zooms back out. So I'm going to zoom in again here on that roost, and I'm going to unclick reset zoom. So as I'm moving forward and back in time, it doesn't keep scooting me out. All right, so this is definitely what I am looking for. Okay. So when you're looking for it on the ground, you want to go back to the beginning of when they're dispersing, right? So as they get up in the air and disperse out, they could be blowing with the wind. There's air that is involved in when you get farther away from the radar station. So basically, you want to get back down to the beginning of that little radar explosion. So we're pretty close here. Let me back up one and see if it's... You basically want to go back until it disappears and then go back one forward. Brad, you're correct. It would. If you look at a radar, and sometimes this is useful, if you have a roost that's lost in that blue stuff, which the blue stuff there is insects and leaves being blown around and dirt. And we'll go into all the different things that radar can see in a little bit. You can move to a radar farther away to get away from that and get a clearer picture of that roost. However, you're looking up high again, and to get the most accurate location, you want to look when it's as close to the ground as possible. The beam is as close to the ground as possible. So I guess there's a sweet spot that you want to find where you're close enough to a radar station to where it's not obscured in all this clutter, but not so far away from a radar station that it's inaccurate. So, and that's what I do sometimes. You poke around, you look at that map of all the radar stations, and you pick another one. Maybe I get a better angle at it. Okay, it's almost gone. Let me back up one more. All right, completely gone there. So I'm going to zoom in. This might be it right here. You guys see this little thing of green. If you've got green, that's a pretty strong signal, like rain level of strength. And we know it's not raining here. So let me go forward one time just to make sure I zoomed into the right spot. So I'm just bouncing around back and forth. Okay, that's definitely it. Okay, back it up to where it's just those couple of pixels. I'm going to zoom in even closer, and we're going to put a mark on the map. And this is going to be our guess on where this roost is. So up here at the top of this window, there's this, to the right of the little book, is this thing looks like a little push pin with a question mark. Click that, and then I'm going to go to what looks like the highest reflectivity area, the highest color on this range here. And I'm going to click it. And it gave me this. It threw it over on my other screen, but it pre-fills all this information. I don't like having it because it really clutters up the map. So I usually just delete it and give it a name. So this is our test. And then I get rid of this other information. You can leave it. Feel free to leave that on there. That actually is decent information. Just, I usually have a good idea of what I've put that pin on. And, once you have that saying what you want it to be, click add. All right. So there's our little pin. You can close that. All right. So how do we figure out where that is? Or do you want to, sometimes you want to look at the habitat around there just in the software here and take a look at it, see, if you can guess what the habitat they might be using. So you're going to click over here on layers and you're going to go to background maps. So as you saw before, when we first started up the software, it was just black. It didn't have any kind of map of the area. I just had highways and I think rivers selected and maybe state outlines or something like that, just to generally find my way around. Some of these don't work, but what you want to do is world imagery. So click that. And then even though it says auto refresh, you need to hit refresh. Okay, and then it's got behind here, behind this weather radar, is the picture. You can kind of see it peeking out here. But we need to turn that radar level layer off. So back here on the layer selector, where we just did the background maps, I closed it, but you didn't need to. The left tab is data layers. And you can make your radar visible or invisible. So we click that off. And we can see here where our estimate was. Looks like a lake. Looks like our estimate is over the water. It's probably not likely that the martins were swimming in the water overnight and took off. But hey, maybe it's this thing, this island right here. So let's figure out what this island is on the map. It doesn't give you names of anything. It can give you city names in the software, and I'll show you guys how to do that. But usually I'm referencing back to Google Maps. So let's find Google Maps, maps.google.com. Let's get a little look at where I live here, I guess. All right, we're going to switch it to satellite view, and it'll kind of match what we had in the software there. And I'm going to go down to South Carolina. And you can reference back and forth, but I happen to know that it's this lake right here, because here's Columbia, where the radar was, and we were a little bit northwest of it. Lake Murray is where this is. Some of you may know now what roost we're looking at. So it looks like, let's see here, this island matches up. Let's flick back and forth here. All right, try and find our bearings. There was this little point that came out here, and kind of due east of that, the first island that looks like maybe a little baseball cap is that location. So here's the point, here's the island. That is Baum Island, and that is one of the largest purple martin roosts in North America right there. But it didn't look that big on the radar, right? So we're really accurate with where we thought that was. That's, less than a quarter mile away, probably. So this says it's 2,000 feet for that distance. We were probably like right there with our dot. So really accurate. And that's so accurate because this roost was close to the radar station, which means that the signal beam was still fairly close to the land surface, and that means that it didn't scan the birds and before they got super high. They were still just taking off at that point. So I'm going to turn the radar back on, and I'm going to back out a little bit here, because we had those other roosts that were nice and big, right? A little bit later. But where were they? I guess they're not visible yet because this one's just starting. Let me skip back forward. What was it, 1021, where we tried? Let me load that one back up here. Am I not far enough out? Where are they? Yeah, I guess they're farther out here. All right, so, our roost, even though I know for a fact it's one of the largest, because it's a huge tourist destination, lots of people know all about it, it doesn't look nearly as impressive as these other ones out here, which they might be big too. I don't actually know which ones those are. But what's going on here is this is just sampling them while the purple martins kind of disperse in like a exploding sphere. So that's just the smallest part of the sphere, but it's most dense right there. And as it expands out, we lose that signal on here. So there's benefits and there's costs and benefits from where the roost might be in relation to the roost. So I'm gonna scoot forward in time a little bit. So it's like almost disappearing already. But remember I said that there's multiple angles of the radar. Since we're so close here, we can look at those higher angles. And that's what this is right here, elevation. 0.48 degrees is the lowest. It looks like in this particular mode of weather radar, it was doing 2 scans at the lowest angle, 2 scans at the next angle, and then a couple of more. So let's go to the next angle up, 1.49 degrees. So you click that and hit load. Let's see what it looks like. Okay, so you can see here, it's a stronger signal. The circle's bigger because that's, the dome higher up in the atmosphere. Let's try 2.5. Okay, wow. You can see there, that's a lot of purple martins. So let's go back to the lowest one. I'm going to scoot out. I'm probably going way too fast for everybody, aren't I? I apologize. Where we got these other roosts, we know. Let me back up to where we can see our one here as well. Okay, we got that one, we got this one, we got this one. Let's make sure that those are birds and not some weird rain event or something like that. And maybe there's even another roost hiding in here somewhere. So here we got this pull down in the radial properties where we did the angles. And we're set at reflectivity, which is your standard radar. When they talk about, reflections from storms, that's reflectivity. And that's why this kind of blue-green, everything looks normal to what we'd think. But there's these other products here. Radial velocity is looking at if whatever the reflection is moving towards the radar station or away from it. Sorry, Brad. I'm going to try and slow down, but I've got so much I want to talk about, to really get you guys up to snuff. And this is really cool stuff, what you can do with what originally was just, for looking at rain. Radial velocity looks at like I said, if something's moving towards the radar station or away from it. So if you've got a ring of purple martins, let's see this way, expanding, and your radar's over here, you've got half of the burst going towards the radar station and half of it moving away. So here's the radar station, here's the ring. So presumably this half is moving this way and this half moving that way. Same with this, same with this. So let's pull and click radial velocity and then hit load. And you get a very different looking map here. But when you have these two-tone things, you got green right next to red, you know that that's something that's expanding in a circle. So you can pick out, we've got a purple martin roost here. I'm pretty sure of it. This is also a purple martin roost. And this is, if you're just looking at a single slide, you're not doing the scrubbing forward and back in time like we did to see things grow and shrink. This is a good way to just take a single slide and say something right there, something right there, something here, even though we're kind of in the woods. Let me back it up one. Okay, you can see it as we zoom in here. We got red and green. Okay. This stuff here is a little less organized. You got dots and dots. But over here, we got a couple of things here that might be worth looking at, right? We got this little guy. Looks like a tiny little one. Maybe something here. Maybe something here. So in that initial map with all the blue stuff everywhere, these were hiding. And there was another one hiding somewhere. Maybe that was on a different map I looked at earlier. But, these are lost in it. So, come on. Let's just go back to that reflectivity one here. So, I mean, that looks there's dark green things there, but they're not really behaving like purple martin roosts, in that you can't really see them exploding because they're smaller. Another thing that you can do, if you have a lot of stuff like this, a lot of this clutter, these bugs, other birds, leaves blowing up in the air, you name it, you can click another one here called correlation coefficient. You don't necessarily have to know what that means, but I'll show you what you can use it for. So we'll just select that and hit load. All right. So correlation efficient, I believe, got to remember back to my radar training, is looking at how spherical the raindrop is, or whatever's reflecting. I think that one was correlation coefficient. And raindrops, hail, snow are pretty round compared to a bird with its wings out or garbage in the air flopping around. And those, even though we don't have any rain here, it would be this red. So one is like perfectly spherical. So if we had a bunch of rain and purple martin roost and we're trying to pick it out in the rain, the red stuff would be everywhere. And your lower numbers here, your blues and your greens and some yellows, are things that aren't rain. Birds in particular are very not round when they're flying. So that's why this purple martin roost right here is super blue, super low correlation coefficient. We may have another one that we'll look at that shows that. So let me just go back to reflectivity before I forget to switch it back. All right, so that's best case scenario. I mean, we practically put a pin right on where that roost is. I knew that there was one there, but that's the way it'll be with Project Martin Roost. You'll know that there's one around somewhere. And it's just how accurate is it, and has it moved from the year that we put that yellow dot on the map. Okay, so we're gonna go to another scenario here, and this one is actually our roost here in Erie, Pennsylvania, Purple Martin Conservation Association. I'll show you where is it? We are right here. That's where PMCA headquarters is. And we're actually in one of those areas where there's not ideal weather radar coverage. We've got Cleveland, we got Buffalo, we got Pittsburgh, all about equidistant from us. So there's no weather radar getting to us until it's fairly high up in the air. So it makes it a little harder to find a purple martin roost. So we're going to use the Buffalo radar. So back here on the data selector, KBUF is Buffalo. It's 2 above what we were previously on. And our roost isn't really active right now. So let's go to what it was doing last year. Let's go to August 15th of last year. So you click the pull down for your calendar, and let's click it on back and click August 15th. I'll give you guys a second to catch up with me there. Sorry, Aubrey. Yeah, it should be recorded. Yeah, it's a lot to take in. All right, while you guys are getting that pulled up, I'm going to look up what the sunrise was in Erie, Pennsylvania, August 15th of last year. August 15th, 2019. All right, it was 6:28, and we're Eastern time zone, just like South Carolina, so we're going to add 4 hours since it's daylight savings. Remember I mentioned that we got to add that time, and it's important to know if we're daylight savings or not. So we're going to be looking at 10:28 for our sunrise. Hopefully you guys are all to Buffalo and the right date. and let's go 1021. And since this map is looking at South Carolina right now, let's click reset zoom and load. Why didn't you move? Oh, I made a classic mistake here. You guys may have done it too. We clicked Buffalo, New York up here, and we clicked the right date, but we didn't do list files. This is just another one of those things with this software. It doesn't automatically give you the new scans for that location until you hit list files. So my mistake. So I hit list files, and this gives me all the Buffalo radar station for that day. And what did I say? What was it? 628. Which is, look, we got 1028 exactly. So this is exactly sunrise. I got reset zoom selected here to move it. All right, this is it. Okay, this really likes getting in the way. All right, so we got some weird looking things here. Not your lovely circles like you're used to seeing with Purple Martin Roost signatures, and that has to do with us being so far away from those radar stations. So here's the Buffalo radar. Over here, where this signature is over a mile away, or not over a mile away, 82 miles away, over a mile high. But there's definitely something here. And let's zoom in. So I'm using my scroll wheel. You guys can use the little magnifying glass. This is Erie. It's got that little peninsula there. That's actually where our research colonies are, out on the peninsula. Our headquarters is right at the neck of that peninsula. But if these birds are showing up already, then we need to go back in time a smidge. So I'm going to uncheck reset zoom so it doesn't kick me all the way back out again. And let's go back one scan. All right, getting smaller, getting higher reflectivity. That's good. Let's go back one more. Okay, even more. Go back one more. Really small, but it's still the remnants of that as we're going back in time, or the early part of the Purple Martin Roost. Let's go one more. 10:05. Okay, disappears there. So I'm going to go back forward one and load it. All right. We don't have to do the turning radar on and off thing like we did with the South Carolina one, because there's none of that clutter because we're so far away. But I can tell you right now that this isn't where the Purple Martin Roost is, because that's out into Lake Erie. So putting a pin there doesn't really matter at this point. But let's say that, maybe it's here or over here or something, but we've got a fair amount of error to wherever it might be. And this was actually a real world problem we had. We lost where our roost was 3 years ago. It used to be, for years and years and years, it was down here. You can kind of see it. It's not the highest depth. Oh yeah, there, that little island right there. That's where it was previously for years. But then it disappeared, and we were trying to use weather radar to find it, and I didn't need to go out on a boat into the lake to know it wasn't there. So I just knew that it was still somewhere, and we had to just do old-fashioned legwork and ask people. I thought maybe it would be out here because they kind of like peninsula things that stick out into the water, or up here. I was guessing the closest land to where that roost was. So I spent a few nights hunting around over here. Saw some purple martins, but didn't see a roost. And then I slowly was kind of exploring around. And this is what you may have to do. This is what you'll likely have to do, actually, when you're hunting for one of these purple martin roosts. It won't put you dead on what it is. It's really uncommon for that to happen. So that was just best case scenario there with that South Carolina, that Lake Murray roost. You know, it's probably in the real world just going to be something like this, where you know that it's, somewhere around here. So you show up at sunset one night, the closest thing to that, or just in the vicinity. Say this is over land, but it's not in the right spot. You would go to wherever that signature was, and right at sunset, get out of your car and look around, see if you can see some purple martins flying one direction or the other. Hopefully you do. If not, maybe it gets dark before you find them. You come back the next day. Sometimes it takes a few days. Sometimes you need to ask locals, hey, is there a bunch of birds around here somewhere? I'm looking for some birds. Showed up on the radar. And they might go, oh, yeah, there's a flock of birds down at so-and-so's house by their pond. But, sometimes you just have to go out there and, look through your sunroof and drive and try and go where the birds are going. And that's what we ended up doing. We were spending a lot of time looking out here, and finally saw some purple martins, and they were going this way. They're actually going back towards land, and where the roost had moved to is actually right here in this little marina area. So, that's the radar stuff will get you in the ballpark, sometimes closer than others. The farther away you are from the radar station, the less accurate it is. All right, so I actually have a real world situation right now. A lady emailed me today, and she's looking for a roost that used to be down in Louisiana. So I figured we could find that roost together. Okay, so she's down in Louisiana. Let me type in the coordinates that she gave me of where the roost was a couple of years ago. So you don't need to do this part. This is just me to get an idea what radar station to have. And latitude and longitude are usually in 2 decimals, or two numbers with decimals. One of them being negative. If you don't do the negative part on the second one, it'll put you on the opposite side of the world. 2, 3, 6. All right, so this is where she said the roost used to be. So let's back out. All right, this is the southern coast of Louisiana, south of Lake Charles. I think Lake Charles has a radar. Let me look at our thing of radars. Yeah, KLCH. So let's look together and see if we can find this lady's roost. She says it's been missing for a couple of years. So KLCH, Lake Charles. And let's go to today. So since we're back in August, you can actually, there's a shortcut to get to today there. Yes, they're on Central Time. Correct. So today's the 20th, so we'll click the 20th, and let's check Lake Charles. Sunrise Lake Charles, 6:25. That's today, but we'll assume that it was 6:25 yesterday. So we're adding 5 hours this time. So 11:25 is what we're going to look at. So we got Lake Charles, we got today's date, list files. What did I say, 11:25 to 11:27. Closest. Click reset zoom so it moves us over there. Oh, all right. Lots of rain in the way. When there's rain in the area, so the two examples we looked at were no rain. The radar switches to a different mode during rain events, so it can scan the weather better. And I have a little page here that talks about that, but basically, you don't need to know about this. All you need to know is that what you want to be able to find purple martin roost the best is clear air mode. And clear air mode starts it's in the 30s, 31, 32, or 35. And I'll show you where you can find that. Since we pulled up the radar here, over here, this VCP 215, that's the mode. So that's in rain precipitation mode. So anything other than what I say, 31, 32, or 35 is not clear air mode. Sometimes you won't see rain on the map, but it still won't be in clear air mode for whatever reason. So instead of trying to fight through the rain here, let's try a different day. Let's try one day prior. Let's try the 19th. Let's move back until we get a clear day to hunt. All right. What time did I say? 11 something? 11:30-ish. Let's try that one. Okay, we still got rain. Still VCP 215. So let's go another day before that. All right. 11:40. Still rain. I guess it makes sense over the Gulf of Mexico in the summer. We'll find a dry day one of these. Go back to the 17th, last Friday. Come on, big bucks, no whammies. Oh boy. We'll get there. I've got a good feeling about the 16th. And this is what you got to do sometimes, you know? Come on. 215. All right, we're going to do it rather than me keep clicking through days. This looks clear enough for us to find something, because I think I kind of see the remnants of something here. So even though I said not to do it on precipitation mode, we're going to do it anyway, because I think we're onto it. All right. So this is, where was it? So this is Lake Charles, which is this little square here. It matches this little square here. Just trying to get our bearings. And she said, looks like basically straight to the coast from Lake Charles. So that would be down here. Doesn't look like that's where I'm kind of looking here, but let's scrub through a little bit here. See if that gets smaller. This will be a good chance for us to, oh, I see something over here. Maybe that's it. I'm going to zoom in. That looks actually really good. So since we've got rain on the map here and purple martins, I'm guessing, let's try the different modes. Let's try the radial velocity. Brad, we'll see if we got time to take viewer requests. All right, trying radial velocity. So I pulled that. I clicked load. All right, that's kind of a mess. Maybe this is something, but let's try correlation coefficient. See if we can. Okay, you can definitely see the rain here. Remember I said rain is red on the correlation coefficient? You can see there's definitely rain mixed in with biological stuff. Not terribly informative, but let's go back to reflectivity. Yeah, you're right, Brad. So this software where it really shines, you know, there are websites out there where you can see unfiltered radar, but they don't have the archives. It's like you have to get up that morning to look at the radar scan before it, you know, gets replaced by the next day or deleted. They're usually kind of a pain to use. Let's go back. All right, so she had it down here. This is looking really good, actually. And for this one, we'll do... Yeah, look at that. It's actually got some yellow in there, so really high reflectivity. Let's back it up one more. See if we can get it to come to a point. Maybe this is all part of it too, maybe. That's a lot of birds. Oh yeah, look at this. Goodness. Almost into the, we get some orange in there. That's a strong signal. Okay, we're shrinking it down. We're really going to get a nice point here. And this is fairly close to the radar, like that South Carolina roost was. Okay, it's pretty much... Is this what's left? Let me go back because I looked away as it disappeared. Okay, I'm going to zoom in so I don't lose it this time. Back one. Okay, so this little darkness right here is where it is. So I'd put a pin right there, and then I'll email her this information. I'm not even gonna change the label stuff. You can see how messy it makes the map, but at least it'll have the information there for me to copy into an email later. So I think this is where this lady's roost is. And I'm going to show you guys how to make the little cool animations, you know, that you can email and put on Facebook and show off to people. So right here we've got animate. See this? Where we've been hitting load before, there's animate. And since we kind of already scrubbed through, you know, the roost from its start to where it ends, let's just highlight all of those. So you can either do... Oh, you want to see where it is? Okay, yeah, let's turn off the layer here quick. I don't know, whatever this stuff is. Louisiana's all swamp, so whatever this swamp is here. Probably got to get there by a airboat, I'm guessing. But we'll send her that. Looks like maybe there's a highway just to the north. That might be a road that goes down. So she might be able to get close. You know, there's like a... I don't know. This imagery, it all depends on tides and, you know, whether it really looks like this. Ah, Charlotte. Are you the one that emailed me? I didn't even really look at the name. Yeah, come back and check this. Write that down, and then you can go try to find it. All right, I'm going to turn it back on, and we're going to do the animation thing to show off. All right. Like I said, we kind of already know the time that the roost starts and then the time that it's pretty big. So let's highlight all of those in between. So you can either do control and click, or click the first one and then go to the last one and hold shift while you click and it'll select them all. Or you can control click on each one individually. So you want all of them highlighted that you want to animate. And then once you've done that, you click animate. So I usually load it to look at it. You can export it, but it's probably not something you guys are going to want to do. You probably want to make your little GIF animations. So it's on load, and we'll hit start. And it's on the other screen for some reason. Here we go. All right, so it goes through the process here. If you haven't downloaded them already, it'll download them in the process, but it kind of chews on them and gives you like a little slow motion look as they're being added together. That's interesting how it kind of becomes a ring there at the end. All right, so that's not how it usually is. It's usually like this from default. All right, so we got our little animation here, and you can play with the slider to go faster or slower. I actually like it pretty fast, because then it kind of looks like fireworks or something. Slow is painfully slow. So I usually go somewhere in here. There's the checkbox for repeat delay. That means it stops at the end. It gives you a little pause before it starts over again. I don't usually like that. And you can do two other things here. So you can see now it's not doing the delay. It's just zoop, zoop, zoop. You can do rock, which is it goes up and then it goes back. It goes up, it goes back, which is really cool. I don't know. I like this type of animation where it's back and forth, back and forth. Or you can just do reverse, which is, I guess it makes sense if you're trying to show somebody where something is, but it's kind of misleading because that's not what the purple martins are doing. But so I'm going to do rock because I like to rock. And then what you'd want to do then is export movie. All right. All over the place here. So you can save it as a couple different modes. I like to just do animated GIFs because the file size is pretty small and they're easy to post. So I'll put it on the desktop. And we'll just name it whatever and hit save. And then it's doing this. And then we'll have a little animated GIF that we can email to somebody that lives by Lake Charles, or just, if it's something cool, you can show them that way. And you can make these really big. If you have a roost that takes a long time to develop, or you want to do an animation of a hurricane moving, you can select, the whole day's worth of thingies. All right, let's open it. Let's take a look at it. And it's on the other screen, of course. Okay, so here's the animated GIF in a window. So you post that for somebody to take a peek at. But that's all you have to do to make it. Couple of other quick things, and then I'm going to show you guys some other stuff that you may get confused with that you might see on radar. So these are like fake purple martin roosts, I guess. But if you're another thing that might help if you're right up here, close to a radar station with all this blue, all this really low level reflectivity, there's a filter. So it's here under tools, data filter. And minimum value. So this is the reflectivity. These are the values here. So all this light blue stuff is like, reflectivity can actually be in the negative dBs. So the dark stuff doesn't start till like maybe between 5 and 10. So it's got a pull down here and all it has is 20 and 40, but you can type in whatever you want. So I'm just going to put let's just do 3. See what that looks like. So minimum value of 3. And let's do reload. See if it cleans this up a little bit for us. A little bit. In some situations, it may be when we're in clear air mode, because remember we're in rain mode here. That might help. Let's go a little bit farther, just to see out of curiosity. Let's make it 7. Yeah, so I mean, this is really tightening it up a little bit here. So, maybe since we're experts now, we know what it means when there's the light blue there. But, it might help people to see it if you get rid of some of that extra clutter. Tim, blackbird roosts do show up on radar as well. And some of the roosts in our Project Martin roost, some of the dots on that map might be blackbird roosts. I'm sure that we have combinations. I don't know. Jane, you tell me. I'm not familiar with the area. That may be where the Gibbstown Bridge Roost might be where it used to be. I don't know. All right, I'm going to close out the... Actually, I'm going to reset the filter back to nothing because I like it when it's really messy. All right, and I've got a couple of just interesting false alarm stuff here. All right. So if you guys can follow along if you want, because this stuff's kind of cool. So we're going to go to Laughlin Air Force Base, KDFX. I don't want to keep you guys too much past the time that we were scheduled to go. What did I say? KDFX? Where is it? Laughlin. And April 19th, 2018. I'm going to click this about a million times. I guess I could just type it in, but what did I say? April 19th, 2018. And list files. And we're going to look at is that right? Or 1918. All right, and we're going to look at the first scan there. Oh, I forgot to hit reset zoom. It doesn't do us any good to look at Louisiana when we're supposed to be looking at Texas. I think this is the right date. So we got a little line there. That's interesting, right? Ah, something happening over here. We'll talk about that line in a little bit. But we definitely got something going on here. Look at this thing go. Ugh, reset zoom. It's the bane of my existence. Definitely looks like purple martin roost, huh? Got one here. Looks like another one starting here. Maybe something down here. So what we have here is actually not purple martin roosts. And I picked an obvious date to to help us with that. April, which we wouldn't have a purple martin roost then. Also, you can tell from the time. This is... God, I don't know, at night. This is, I don't know exactly, what are we subtracting, 5 or 6 or something? So that would be like 9 o'clock at night. This is actually bats. These are all bats emerging from caves in Texas. But this is something that could be mistaken for purple martin roost. The biggest clue is that it's at night. Purple martins don't emerge at night. Actually, you can't even really see them condense and come to land at night, just because they're too dispersed and do it slowly. It's not like in the morning when they... So bats can look like purple martins. All right. We're going to go... KSGF, Springfield. KSGF. There it is. And we're going to go even earlier. We're going to go July 24th, 2017. July 24th, 2017, KSGF. Click it. Don't forget reset zoom this time, Joe. And we're going to go to 2022. There it is. Okay. Looks like we got some rain here, right? Let's progress here and see what I was trying to look at. kind of see something weird going along around the rain. You see that? Looks like little circles around the rain. And they're expanding out. So what this is outflow from a storm. So when you get a big heavy thunderstorm, all the rain coming down at once pushes the wind out. Sometimes it's called a gust front. It's basically when a storm's coming, you feel that like it gets gusty right before it happens. That's what this is. So this is birds, bugs, leaves, dirt, everything blowing out in a circle from a thunderstorm. So this could definitely be mistaken for a purple martin. So this is going to have the same signature as birds when you look at like the correlation coefficient, because it's garbage and there are birds in there as well. Time can be a clue, but usually the presence of a storm kind of centrally located is probably a good bet that that's an outflow pattern. All right, let's do KTLX. Oklahoma City. And we're going to do May 5th, 2018. List files, and we're going to look at 1:31 Zulu time. So this is right at night. And what I want to show you here is just at nighttime, you get this explosion of the blue that we were seeing elsewhere that was, you know, the biological scatter, the bugs and stuff. But at sunset, you see it explode like this. And that you could potentially mistake that for a purple martin roost as well, just for the fact that it's a exploding circle, growing as time goes on. And that's just more and more insects and dirt and garbage and everything. Well, I guess this one's not dirt and garbage because it's not wind related, but insects, nighttime bird migrants, which purple martins really aren't. But during migration periods, you'll have all the birds take off at night as well. So that's something that you might mistake with purple martins. And there's actually some cool stuff you can see on radar as well that's you wouldn't think you could see. So let's go to KDAX. KDAX. Sacramento. We're going to do May 5th. Oh, we're on the right date. May 5th, 2018. All right, so list files for that. 2304. So all the way down here. I think that's right. All right. Got this. That's weird, right? Let's see if it moves. No, not moving. No matter what time of day you look at this, it's going to look like that. And that's because this is a wind farm. That's those are windmills showing up on the weather radar. So you can have weird stuff like this show up that, you know, it's kind of a circle. I think, oh, this might be a purple martin roost. Now, that one is windmills. KPUX. KPUX Pueblo, Colorado. Oh, I don't have a date for this one. Darn it. Well, that one was going to be smoke from a forest fire. Kind of shows up out of nowhere. Usually it kind of has a trailing, you know, the part where the smoke's coming up obviously doesn't move, but you have just a growing swath that goes off in one direction with the wind. Let's see what else. Oh, let's do this one. This one's super cool. KMAF. Where are you at? KMAF, May 17th, 2017. May 17th, 2017. Yeah, Tommy, this will be, not Tommy, Tom Finney. I combined your name there. Tom, this will be archived and you'll be able to watch it. All right, so what did I say? 0119. Load. Oh, forgot to reset Zoom. You know, as much as I've done this radar nonsense, I still forget almost every time. All right, look at this weirdness. We got two straight lines. Let's move forward and see what happens. It's definitely rain up here, right? Hey, this might be a good opportunity for us to look at correlation coefficient. You can see the difference. Yeah, this is rain like crazy right here, right? All red. But here we got some blue, some pink, some of this kind of weirdness, yellow. Definitely not rain there. Switch back to reflectivity. Let's keep moving and see what this does. Oh, they're moving together. Anybody have a guess what this might be? See what happens when they hit. If they hit. Thanks, Tom. Trying to balance between going slow and not being super boring for people. So I completely understand that folks are needing to watch it again. Sometimes you'll see these weird straight lines come out. And that is usually the sun hitting the radar station. Like it perfectly in line with the radar antenna. So it's just like, and sometimes you'll see areas where there's nothing, almost like a pie shape of nothing. And that is a shadow from a building or a mountain. So if you see like a full like triangle of the radar section missing, it's a shadow, a radar shadow. All right, let's keep these guys moving together. I sure hope this is big enough on the stream for you guys to see. I didn't even think to look. All right, they're colliding. Yeah, Aubrey. Yeah. All right, they're hitting each other. What's going on? All right, it looks like they're just kind of combining into one. But it is kind of in line with this rain stuff. Let's see if it does something as it combines here. Because what this is a cold front and a warm front. There we go. Now they're exploding into storms. So those were both, two different weather fronts ramming into each other. And all of the dirt and junk and everything that, it was just on a collision course. Now look at this. It's going crazy. Yeah, you're right, Veronica. You can waste hours just poking around here, looking at storms, looking how they behave. When there's a tornado, you could pull it up and see what that looks like. They have like a little hook shape. You can definitely see it with the radial velocity because half of the storm is spinning towards the radar, half of it is spinning away. So it'll have kind of a two-tone thing like the purple martin roost did, only more in like a spiral shape. And when it hits something, the tornado hits something, you get debris, and that shows up like debris and birds and stuff with correlation coefficients. So when you look at a storm and there's a tornado, if you click over to, that's one of the ways they know that a tornado's hitting structures or trees or whatever, because they see that kind of a bloom of stuff on the correlation coefficient. So yeah, this was two fronts hitting together, and then they turned into storms. There were a couple other things that I didn't have time to find, a date and a time where it happened, but I thought it might be cool just to show you guys. This, you can sometimes see traffic on the interstate. Depending on the weather conditions, sometimes the radar beam gets curved down towards the earth, and it'll show cars and trucks going along the interstate. It'll look like a line of yellow and red stuff. And you'll see it, if you have on the software, the highways turned on, you'll see it like a line that doesn't move. That's just right on there. This actually right here, I don't know if you guys can see this. Let me zoom in a smidge. All right. So this is El Paso, I think. So you see this little red thing that goes shooting away here? Not the green, but starting right here. There it goes. That's actually a train leaving a train station. I thought that was super cool. You can see it drive away. And then the last one that folks a lot of times like to look at is in the center of a hurricane. Once it hits land, you can see the birds that get stuck in it. Birds, hurricane comes, the birds are hunkered down, and, the eye of the hurricane comes up, and they're like, oh, it's over. They take off, and then the other side of the eye wall hits like a ton of bricks, and they don't even have time to land. So they're just stuck moving with that eye of the hurricane, and you can see that over time. So this is the reflectivity here, so it just looks like rain when you look at that. But this is correlation coefficient or something else that discerns. I guess maybe it's correlation coefficient with just a different color code than what we were looking at. But that's non-rain right there. So I think that's it for a couple of minutes over. Sorry about that, guys. I hope it was time well spent for you. I can't wait to see you guys go out and find purple martin roosts for Project Martin Roost. I can't wait to have all of your roost reports come rolling in. It's useful for roosts that are known and roosts that aren't, because sometimes they move. All right, Brad, your question. Time is Zulu time, and in Central Time Zone we add 5 hours. It depends on daylight savings or not. So on daylight savings, you add 5 to Central Time. If it's standard time, you add 6. I guess for those of you who still might be around, we could do question and answer for a few minutes if you want. Otherwise, you can bail out. I can't even see how many people are here, so you might all be gone. Anyway, hey, Charlotte. Good. I'm glad you guys liked it. Bill, good to see you in chat. Hopefully it gives you something to play with. Looking around southwestern PA for potential roosts. Cool. Hey, Paula. Yeah, we're not going to have an official roost event due to the pandemic here in Erie this year, but once we verify that the roost is active and the location, we'll put something on social media about it. Oh, thanks, Brad, for the update on viewership. Any other questions for folks? Oh yeah, you had a request, right? Sorry. My cat wanted to say hi. This is Cilantro. She's been keeping me company while I do this. Radar real time, Aubrey. Yeah. If you refresh the thingy, the scans as it goes, you'll have it up to date. With so they show up there as soon as it scans. Tom, the archive broadcast, I think Facebook just holds it, but we'll also download it and put it on YouTube because I know a lot of people wanted to watch but aren't YouTube fans, which I completely understand. So we'll be putting it over there for them. Tim, cool. Can't wait to hear if you find the walkie roost. All right, Brad, where was that? What? I got too many windows open here. All right, so you wanted me to find an Alabama thing? Thanks, Sue. We got a couple of cats. That one's my favorite. Don't tell the other ones. Charlotte, sounds like an awesome adventure. All right, Jane. First week of July, historically, with the roots. All right, the roost in South Louisiana has been first week of July historically, but if the roosts further north or later, why don't they stage in Louisiana later in the year as well? It's a good question. There are researchers right now that are working on it. In particular, those ones that are doing the radar work. They happen to also be looking at usage of roosts during a southern migration. So looking to see if, birds from Canada will also stop at Oklahoma City roost on the way down, or do they just fly down and stop wherever they want, or do they use that roost that other birds are at? And seems like maybe there's a combination of birds doing that. Brad, near the convergence of the Alabama and Tombigbee rivers. Oh my gosh, I'll be able to do this on the screen, on the stream. Brad, if you want to email me, I can, or with the information that you've been given, you can try to find it yourself. But if you want to take the easy route, you can just email me, joe@purplemartin.org, what you're looking for. I find roosts for people all the time. Calvin, what would you estimate the minimum number of birds is to show up on radar? Awesome question. I don't know. Less than 10,000 seems to maybe still show up, but I don't know what the minimum is. And I imagine it depends on distance from the radar station. A smaller amount of birds would be really dispersed by the time it got up to a certain altitude. So if it was really far away from a radar station, it may not show up on a high beam at all. So I really don't know. Visited last year's roost in Miami on July 7th. Is it unusual for a roost to take place in a shopping plaza off a major highway? Surprisingly, no. In the southern states, especially, it seems like roosts are a lot of times in urban areas, mall parking lots, in the trees, obviously, not sitting on cars or whatever. Bridges, that sort of thing. It seems like in southern states and southern areas, that's more common than. Exactly. You're right, Veronica. Yeah. So especially in Texas, like the Houston roost, the one north of Dallas, McAllen, Texas, a lot of those Texas roosts, some of the Shreveport one in Louisiana, a lot of those are in urban areas. And I don't know if it's that there are, I don't know if it's a habitat availability. Maybe the same habitat that they're using in the northern parts of the country aren't available down there. Fewer lakes, fewer wetlands. I don't know. Something we're trying to find out. And the way that we're going to find that out is to have you guys go out there, visit those yellow dots, and tell us what's there. Is it purple martins? What's the habitat like? Like I said, we've only got a best guess on where those are with that yellow dot. We don't know where the roost actually is. Yeah, Paula, the Tulsa roost is an interesting one. It seems to, or at least the last few years, has been troublesome. It's been at the airport, which is really challenging because they don't want the birds to bring down any planes, which is certainly a possibility with a huge flock of birds. But then again, we want to keep the birds safe, and it's hard to convince a huge flock of birds to move, because the whole reason that they're in a flock is to have safety and not really be that worried about an individual threat. So like you got 10,000, 20,000, 100,000 purple martins. You're not worried about a hawk flying by because it'll catch somebody else and then eat it. So they're at the airport in Tulsa. They were trying to scare the birds away with noise and firecrackers and whatever. Well, the birds just kind of shrug it off. So it's been difficult. Brad, any ideas on why some roosts seem to stay in the same location for years and years? Some seem to move every year. Roosts that aren't harassed. I know harassment makes them move, but some move with no harassment. Don't know. Certainly harassment does contribute to it, but you're absolutely right. Some that aren't harassed end up moving, and we don't know. I mean, if we knew how purple martins made decisions, it would make our research a heck of a lot easier. But yeah, the disturbance of the area, changes to the habitat over time can lead to that. But sometimes it's just, I don't know. I mean, it's, how does a flock start? There's one bird, right? That then another bird looks at and wants to go with. So maybe it's just like the butterfly effect. You know, whatever that bird was that started it went somewhere else, and then everybody else followed along. It's difficult to say. You end up in philosophical grounds with that. Okay, I think we're going to call it there, guys. So thank you so much for joining. I'm glad you guys were here, and I'll try and figure out how to shut this stream off. But I'm glad you guys watched, and I think it'll be available just in our videos on the Facebook page. If it's not, if it's hidden somewhere, I'll make a post that links to it wherever it might be. So thanks, guys. Appreciate it. Happy hunting. You're all radar arrow ecologists now. Bye.